Hello, my name is Francisco Peña. I'm a postdoctoral researcher working jointly at Stockholm University and KTH, and I'm going to present to you the work that we have been doing with digital futures. That is called, our project is called Deep Wetlands, and it's about quantifying the water extent changes of wetlands using deep learning. This work, we have been doing it together with Fernando Jaramillo from Stockholm University and Amir Peira from KTH. Basically, we're trying to solve three research questions, and is how can we quantify the surface water extent of Swedish wetlands at every point in time? How can we accurately detect the quantity of water hidden under the vegetation? And how have the Swedish wetland surface extent changed in the last 10 years? We have two main motivations, one from the hydrology point of view and one from the computer science point of view. Regarding the hydrology, we want to preserve wetlands. They're extremely important for the environment. They sequestrate the carbon monoxide. They act as barrier to prevent floods. They purify the water that we consume, and they're home to a great diversity of flora and fauna. The problem is we don't know which of the wetlands are degrading, so it's very difficult to know which ones we should try to preserve. Regarding deep learning has shown superior performance on computer vision and image recognition tasks, which makes it ideal to use along with satellite imagery to monitor the wetlands. However, we have a big problem, and is that deep learning requires large amounts of fieldwork data to train models. To overcome this problem, what we do is we rely on optical imagery and on a technique called normalized difference water index. Basically, this technique allows us from optical imagery to detect water with high accuracy. Then, using these over thousands of images, we create a lot of water masks that we then give to a deep learning model that uses SAR images, and basically this model learns to imitate the optical output from the input radar imagery. We see some results here of our project, and we see that even though the radar images on the left-hand side are very noisy, our model is resilient to noise, and the results are very similar to the ground truth. Moreover, we're able to monitor the change of the wetlands, water extent over time. We can see some interesting patterns here where the level of water is quite high during the spring when the snow melts. It shrinks during the summer, and then it increases with the autumn rains. That's it. Thank you very much. Bye-bye.